Hello, my name is Kieran Lang.
My name is Jordan Giles.
My name is Miri Savage.
My name is Kenny Wardlaw.
My name is Jacob Del Toro.
My name is Jordan Mingo.
My name is Michael Benben.
My name is Corey Beasley.
My name is Landon Johnson.
My name is Ryan Davison.
My name is Daniel Soto.
And my name is Austin Farrar. Today we're here as a mechanical engineering group working to give you guys information about co-ops, internships, and leaders in the mechanical engineering field here at Georgia Tech. We'll give you all of that in one PowerPoint. Here we go.
Engineering focuses on motion, forces, energy, and materials to design, manufacture, and prototype new products. Because of this, it's needed in almost every industry, and it's among the broadest fields of engineering. And there are specializations that range from energy to robotics.
For our interview, we interviewed Christy Mahaffley. She's an academic advisor in the Woodruff School of Mechanical Engineering, and she told us a couple of major things about her career, both here at Tech and afterwards. First off, she co-opted, at Ford Motor Company, and she worked in the electronics division, working on some electronic parts there as a mechanical engineer. She also took those skills she learned there and applied those when she worked at BP Oil for a significant period of time after graduating. And from those main points that she told us about her career and her experiences at Tech, we kind of gleaned some major aspects we can apply to our own careers while here at Tech. The major point there being that no matter what skills we learn here at Tech, being a mechanical engineer opens up a plethora of doors for us because we gain a skill set that is so diverse we can apply it anywhere we choose to.
All right, so now in order to get out of tech, there are several courses that mechanical engineers have to go through. Specifically, there are 13 mechanical engineering courses, one of them being ME 2110. And in this course, it's one of our introductory courses where we're able to start designing and being creative with mechanical engineering and all that we're learning here at Tech. And on top of that, we have several courses here that show the general guidelines for what mechanical engineers should be following. And also, several electives are required of mechanical engineers in order to expose us to more other fields of engineering so that we can be able to be more knowledgeable of everything else going on in engineering projects.
There are many major skills that mechanical engineers must know because this is one of the most broad majors. Among some of these skills are critical thinking, instrumentation, machining, design modeling, and computer programming. Critical thinking is very important because engineers must come up with solutions to given problems. Then you have to translate this idea into a draft or a computer image, and then move from the image into a physical product in order to create a solution. And then you program it so it carries out the task.
As much as Georgia Tech creates mechanical engineers, it also creates innovators and leaders to go out and improve products in the everyday market. And ranging from nanotechnology to energy, the field of mechanical engineering is always growing. As you can see, in the next 10 years, there will be a 5% increase in employment rates for mechanical engineers. That is 14,000 jobs, all with competitive salaries and stability for all ME graduates.
Now, regarding the further increase, over the next 15 years, it's actually a 5.3 increase in jobs, which means that there are going to be 102,100 more workers in the field. Now, if you look at the salaries of mechanical engineers, you'll see that at the Southwestern and the Northeastern, they have the highest salaries. The ones in the darkest blue have higher salaries, and that's because those are the most industrialized area, or the areas that are becoming more industrialized, meaning they're going to need more mechanical engineers.
What can mechanical engineers expect to do once they get a job? Well, they can expect to go into one of these 5 fields, including product design, research and development, manufacturing, and systems management. Within each of these categories, a mechanical engineer will have to have specific skills and skill sets required for each job. And some of the jobs that a mechanical engineer can expect to have once they graduate from Georgia Tech include working for John Deere, ExxonMobil, GE Aviation, or even Ford. Your horizons are wide open with a degree from Georgia Tech in mechanical engineering.
Before you graduate, you can earn a vital work experience with our co-op program here at Georgia Tech, which has a 35% participation rate. So basically what it is you alternate an on-campus semester with a co-op semester. So you're in the classroom for a semester, and then you go find a job. And you had a job for a whole semester. And what it does is it gives you great experience related to your major. It helps you realize if you love what you do. And if you love what you do, this experience is great for you.
It gives you an understanding of classroom theory. You get to apply the things you learn in the classroom. You become highly valued by employers, most importantly. Your remarkability skyrockets. The total annual co-op earnings for Georgia Tech is $10.24 million. And while you are on a co-op semester, you have to pay $0 in tuition and fees. So it's co-op. That's the way to go.
Georgia Tech students are well known for their innovative sides. They create many great technology and devices, and they are ranked 25th out of 100 well-known universities for their creating devices. They are also known for their alumni supporting their students in their endeavors to create and impact the world. Some of the research opportunities that Georgia Tech provides is really well known as well. The students all pour their hearts and their souls into researching many things that can help impact the world. One of the things that they research is called energy piles. Energy piles utilize the heat from the ground to help raise and lower the temperature of buildings. They usually use energy piles for multi-level buildings so they can cut down the cost of heating for AC units and stuff. Also, energy piles can be used because they are renewable sources of energy, and they can be utilized always.
Even during your time at Tech, you can innovate and gain experience as a mechanical engineer through research. One such research project has been the improvement of remote control using visual servoing. By nature, remote control has two problems. Firstly, if you're controlling, say, a robot through line of sight, then you must mentally reorient yourself because your left and right may not match the robot's left and right. The second problem is that if you're controlling a robot through an attached camera, the video feedback will be in 2D, making it difficult to manipulate a 3D environment. The researchers' solution to this was to use visual servoing, which, through an attached camera on the robot can orient itself to points of interest in the environment. The researchers hope to, instead of using points of interest, use an uncalibrated method by combining visual servoing with remote control. The user would receive feedback from a 2D camera as well as a depth sensor, allowing them to see from the robot's point of view in 3D, allowing them to precisely manipulate the environment using a controller.
Continuing in the field of robotics, in the past months, Georgia Tech recently made the Durus robot, which they are calling the most efficient walking robot ever created. It employs a human-like gait with a multi-contact foot behavior, such as the heel-toe movement, and this just shows how Georgia Tech is innovative in all aspects. They are innovative with the arched soles, which they employed in order to get that movement down. They are innovative when they put the elastics between the foot and the ankle in order to store mechanical energy when they lay down the heel and then use it in order to lift themselves back up. And with all of these innovations, they're able to just blow past the best cost of transport score for walking robots at the moment, which is 3.0. Georgia Tech has a 1.4. And this just shows how Georgia Tech constantly pushes the envelope in all of their research. And they're still shooting for better, trying to create a robot which can be used in the dynamic settings, such as in the forest or in the fields, in order to run uphill and then be able to perform rescue operations.
In addition to the research being done at Georgia Tech, mechanical engineers are innovating on a day-to-day basis, whether it be independently or through competitions like the Adventure Prize. The Adventure Prize is the annual competition held here at Georgia Tech for undergrad students, which gives them an opportunity to present their project ideas and compete for $35,000 in prizes. In addition, in 2012, the students that comprised the team Cardiac Tech revamped the retractor, as seen here, a device used in open heart surgery. Their design reduced the risk of bone fracture and the amount of blood loss during surgery. This reduces the mortality rates due to post-surgery complications. This is just a fraction of the innovation produced by mechanical engineers through the Inventor Prize, let alone Georgia Tech as a whole.
Again, thank you for watching. This has been an amazing opportunity for us. Have a great night.